Before we talked about how low p-values would mean that we rejected the null and we supported your research hypothesis. Remember, the p-values are about the null, but because the null and the research hypothesis are in opposition of each other, if we reject the null, then we have support for our research hypothesis. And remember, the reason we talk about the null is because we can't really prove a hypothesis to be really true, but we can falsify one. So it's a roundabout way of giving support for your research hypothesis. So I know it's a little strange, but your p-value is really about your null hypothesis. But we take that information and we kind of say, well, if we reject our null, then we have support for our research hypothesis because they are opposites of each other, basically. So when you do your probability, it's really about the null, and you make a sampling distribution, which is the distribution of sample means, and in the middle you have that number from the null. So in our pizza delivery example, that would be 30, because that was their claim, that the average delivery time was 30 minutes. If we get sample means that are either over here in this area, over here in this area, then it's far away from the 30, right? And if you found the z statistic or the t statistic and found probabilities of those or more extreme values, the probability will be low. The p-value will be low. So here we have 30, and here we have a high sample mean. And we want to shade to the right here because that means it's more extreme. So it's more extreme the higher you go, right? Over here though, we have a low sample mean and we want to shade to the left because that means it's more extreme. It's smaller. We want shade to the right. The middle area is the sample means we would expect just chance, right? The sample mean is not going to be exactly 30 if the real population mean is 30, unless it's just by chance. It could happen some of the time, but not all the time. So in the middle here is values that we would expect kind of by chance if the real population mean was 30. So if we get something that on the outskirts here, then we kind of expect that, well, maybe our assumption that the mean is really 30 is false. So if you get things that are far away, then either two things could happen. One, it's just by chance. Just by chance that we get an extreme sample mean. Or two, our null is false. And we will conclude that number 2 happened, that our null is false. But number 1 could also have happened. That's why you don't want to make any big decisions just based on one hypothesis test because we're not 100% sure all the time. But by chance, this could happen a percentage of the time, and that happens to equal alpha. So you could have 3 different research hypotheses, and that tells us how we will shade. So a two-tailed test is when your research hypothesis says not equal to. So we're looking for both extreme values on the low end and the high end. So we're going to shade from our sample mean to more extreme values and also on the other side. So if you have a not equal to and we got a sample mean of 31, say it's here, we're going to shade to the right of the 31 And remember that z statistic was, let's just do it in z's, that was 2. So we're going to go to 2 and make a line and then shade to the right of that. Let's make it in color. So 2 and to the right of that. But because we have a not equal to research hypothesis, we're also going to go to the negative z statistic and put a -2 there. And then shade to the left. This would be the same if it was a t statistic as well. Then if we had a less than hypothesis, then our sample mean would actually, it would look a little different. So this is a one-tailed if it's a less than. And if you were kind of right and you got a sample mean that was, say, 29, then you would shade to like this because it would be -2 here. But in the case if you got a 31, then you would shade like this. You would still say less than even though it's over here. Even though it's on the right side, you still shade to the left because it's less than. So in this case, you get a really high p-value. Your p would be around 0.97. And that would mean that you don't have support for your research hypothesis because you're not going to reject the null. If you have a one-tailed on the higher level, you have a greater than hypothesis. This is what we have been doing in our example. We said that the average time is actually greater than the 30. Then you'd have a -2 here when you calculate your z statistic. And then you would shade higher than because it's a greater than. So the shading depends on the research hypothesis. It doesn't matter where your sample mean is, it depends on what you said. So if it's not equal to, then you make a line where your z or your t statistic is. Then you make a line at on the other side. So if you had a positive z statistic, then you would make it negative and also make a line there. And then you shade to the right of the positive z statistic and to the left of the negative z statistic. So here and here. So in this case, if our research hypothesis was not equal to and we got a 2 for our z statistic, we would put a line at the 2 and shade to the right and also make it a negative and shade to the left. But say we got a -2, then we would also do the same thing. We would put a line at the -2 and then make the -2 positive and shade to the right. If it's a less than hypothesis, then wherever that z statistic is, we would shade to the left. If it's a greater than hypothesis, then we would put a line where the z statistic or t statistic is and shade to the right. Alright, so let's do our example. So in our example, we got a sample mean of 31. So in the middle is our number from the null. So that was 30. And then we got a sample mean of 31. We can also put this in terms of z's. So this is z's and this is the sample means. So you can write it in either way. It might be easier just to put it in z's already as your scale. Then remember our null was that mu equals 30 and our alternative was that mu is greater than 30. So because it's greater than, we're going to shade to the right here. Alright, now you want to find that probability, and you learned that in the last phase, how to find probabilities of shaded areas. So we're going to go to our z table, And you can see that if you go from 2 and then 0, because 0 is the second decimal place, then we're going to find a 0.9772. So that's the percentile though. So this area is 0.772 because that's the percentile, the probability below. But we want to find the probability above. So we do 1 minus the percentile to get the 0.0228. And that will be our p-value for a greater than hypothesis. A less than hypothesis would be the 0.9772. So let's do what if. So like I said, if it was less than, then we would get a 0.977 as our p-value. If our research hypothesis was not equal to, then we would actually double our p-value. But you want to look up the negative z when you have a not equal to hypothesis. So I'm going to look up -2. So it doesn't matter what z you actually get. Look up the negative version of it. And you're going to get 0.0228. And you're going to multiply it by 2. Because for this one, we have a -2 here and a +2 here. And so this area is 0.0228 from our table. But because it is symmetric around 0, because these are z's, this area will also equal 0.0228. So they're equal to each other. So if you just look up the negative version, then you can double it to get both of these. So basically we're just adding both of them together. Or you can just double it. Okay? So you can see here that given that all things are equal, a two-tailed test has less power. So 2 tails has less power than a 1 tail. So if everything's equal, it's harder to find a 2-tailed test significant than a 1-tailed test. So if you can have a less than or greater than hypothesis, you should. Now sometimes you don't know which direction it will be, so you have to do a 2-tailed. So the thing with a 1-tailed is that if you get the direction wrong, then you're not going to find support for your research hypothesis. So you do have to know that's going to be in a certain direction or have a pretty good chance. A 2-tailed, you could go either way, but it will be harder to find significance because you have less power, because you're going to double your p-value automatically, and you want to find that your p-value is less than your alpha level to have support for your research hypothesis. So it's going to be harder to find it, and you have less power.